Hi, in this lesson we'll see how Delta Lake is delivers on the features that we talked about in the previous lessons. How Delta Lake can support asset transactions, can support performance, can support optimization, and all this. In order to do that, we'll go create a new notebook. Go to Home, put it in this folder. So create. I'm going to create notebook. I'm going to call it Delta Test. Yeah, I'm going to leave it as a SQL using this cluster. Create. So now I have created a notebook. Now let's create a table in a standard format, the Parquet format. There's different ways to do that. My easiest way is create table. I call it PQ Parquet. Let's call it Parquet test. Using the format is Parquet as select. I'm gonna add two columns. One as an A. So column A, and which is an integer 1, and hello as B. So just creating a table with two columns, column A, column B. One is an integer, one is a string. It has the 1 and hello, and this is a Parquet table. So run, let's run this cell. So this will create the table, a Parquet table, and it will create it in the default database. If you didn't specify a database, all your tables and all your commands will be executing against the default database. So now this table has been created. So let's select asterisk from Parquet test. You should see now a table that has only one record, 1 and hello. Column A, column B, 1, hello. All right, cool. Let's now try to delete this row. Okay, so delete from Parquet test where A equal 1. So we're just going to delete this row. Let's try this. Failed. Why it failed? Because Parquet files does not support this delete update operation. It can only support insert operations. And that's the problem with this kind of format. Now, let's do this. Let's insert a new record first, or actually let's convert this table, or let's try first to update. So update Parquet test set B equal hi where B equal hello. I'm just doing an update operation. Again, update destination only supports Delta. So you cannot update, you cannot delete from a Parquet file, and similarly CSV files or any other format. Now, let's convert this table to Delta and see whether this is possible now or not. So how you do that? The command is very simple. We'll just call convert to Delta. Convert to Delta Parquet underscore test. So now this table will be converted to a Delta table, which was, as you see now, when you do this, this table will now give us support for this operation, the update and delete operation. Let's first describe detail. Describe detail Parquet school test. It's called Parquet and school test, but it's actually Delta file. So format is Delta now. Used to be Parquet, and that's this destination, DBFS. Now let's go to this destination, copy, percent sh, or it should have, sorry, percent sh ls, this location. So you see, this is the folder that has delta underscore log. So there's a folder here called delta underscore log. So it's a Parquet file. The Parquet file is there. This is the Parquet file. It's a really long name, right? However, next to the Parquet file, there is a delta underscore log folder where everything, let's go inside this folder underscore delta underscore log. Let's see what's inside. You see there is some JSON files, CRC files, checkpoint files, and so on, temporary. This is where all the changes that you will do to the table will go in here. Now let's make some changes to this table. Let's do the previous change. Let's run the same cell, the one that deleted one record, exactly same cell. I'm gonna judge if the code, so I'm gonna rerun it. Now this should succeed because the table now is delta, and with delta you've got, you know, all the update deletes supported. So it has said none of the affected record is 1. If you select from this table back, you can see 0 rows, no results. So we have deleted the record. Similarly, you can insert into Parquet test values like an A and B values. Let's take it 1 and test or high 1, another record 2, high 2, so on. So I just inserted 2 records in this table. Again, 2 record has been inserted. If we selected, where is the select statement? We can run it. You should see now 2 rows are there. Now let's update one of them. So there was an update statement in here. This is the delete, convert. Yeah, there's update. So update Parquet file set b equal high, where b equal high 1. Let's put b equal high 1. Same update statement that failed before is now going to run successfully. So now we should see high 1 become high now. So if you run the select again, now high 1 become high. So you can update, delete. Now let's check the delta folder, this one here. Let's run this command. Now you see there is a load of stuff that has been added. This is the changes that you have seen of the delta. So let's describe history Parquet score test. Let's see how many history. So you see, when I say describe history to the table, you see this table have version 1. Let's sort here. Version 0, version 1, version 2, version 3. And there is the operation that was performed. So we convert, version 0 was a conversion. So we converted from Parquet to delta. Version 1, there was a delete. We performed a delete operation. Remember when we deleted the first record? Version 2, we actually appended some records or inserted 3 records. Version 4 is, we got update operation. So select asterisk from Parquet underscore test version as of 3. Or let's take version 2. You see, this is version 2. Remember, it used to be high 1, high 2. Now we removed it. We updated high 1 in version 3. So version 2, I can select from version 2 and see the older version of the table, the older image or the snapshot of the table before the changes has been through. And this is really, really powerful. If I wanted to restore this table, I will restore table Parquet version as of 2, if I wanted to do that. Every command in delta, all you need to do, so let's say I wanted to restore. So delta, you say delta restore command. First result, data breaks. You see here, restore, and then you put the table name, to time travel version. And there will be an example. Restore table employee to timestamp as of. This is a timestamp version. Restore table employee to version of as of. So let's run this command. Copy. I'm gonna go here. Let's restore this table to version 2. Restore table Parquet. Score test version as of. This is version 2, so we want it to version 2. So now your table will be restored to version 2. So if you run the select statement to this table, you should get the data as it is from version 2. So I'm just restoring the table, basically. And this is really super powerful because, you know, if you do this in some tables that has some sensitivity, like if you make a change that doesn't go well, you can restore the data. So if you select asterisk from Parquet, score test, now you got everything restored back. One thing also, you optimize. Let's try optimize table Parquet score test. Actually optimize without table. So this is like I'm optimizing the table. Optimizing the table means I'm compacting the small files together. And Delta will tell you here what happened exactly on this one. Let's Z order. So optimize, the Z order command, optimize Parquet school test, Z order by A and B. Let's do that. So I'm doing a Z order for this table. So I'm gonna rearrange the files in the table to make sure my reads and writes are all perfectly fine. You can also, so now I'm basically run the command without any order because I think this is just a newly created table. So there is a certain rules around how often. There's no 100 hours or 200 hours in there, but just to be sure that this is the number of files. So I'm just going to vacuum without any conditions, and Databricks will remove the unused files. Like I said, the command of the vacuum just remove the storage that you don't use. And this is pretty much what you would do with Delta. So with Delta, it's so powerful. It allows you to manage your table in a way that makes it easy for you to do inserts, update, delete, asset transaction, optimization, restoring the table, doing time travel with version as of, vacuuming files and old files, and so on. Delta is really the way to go. And if the first thing you would do when you create tables in Databricks, or you read data from the source system, or reading data from anywhere, make sure that the first step that you would do is to use Delta. One last thing you should also consider is sometimes when you work with a really big data and you're using Delta, there is a nice feature of the Delta, which is Delta Cache acceleration. So what is this? What does it do exactly? If you create a compute, right? You see the worker type in here. If you select, there is several types of worker. There is some worker that has Delta Cache accelerated feature. What does it do exactly is every time you read and write the table, it will go to read it from the cloud storage, like the S3 storage or the EDLS from Azure. But if you're really doing a lot of reads and write against this table, you're better off if you use a cluster that has Delta Cache accelerated added to it. So this cluster will be equipped with an SSD drives that caches the file to the local storage of your drivers and workers. So your operation of read and write doesn't have to travel to the storage, the cloud storage, and read the data. It can read it from the local SSD, which is really super fast. Again, it's only supported for Delta tables. And this is one more good reason why you should use Delta for all your tables. Because Delta not only gives you optimization, asset transactions, faster reads and writes and all these things, it also gives you caching, which is in big data is really crucial to make your queries faster, performance, and optimized. So that's it for this lesson, and see you in the next lesson.